12.6 goes over multiplying, dividing, and simplifying radicals. The first thing that we are going to look at is simplifying expressions that contain radicals and making sure that we rationalize the denominator that's given to us. So if we look at example 1, we have for A, 3 over the square root of 5. We have to rationalize this denominator, so we're going to multiply the top and the bottom by the square root of 5. So that way we are not left with the square root in the denominator. So this is going to give us 3 square root 5 over the square root of 25. The square root of 25 is 5, so that's 3 square root 5 over 5. This is in simplest form since the 3 and the 5, the 3 in the numerator and the 5 in the denominator, cannot simplify. Even though you have a 5 up top, there is a radical over it, and it cannot be simplified with anything that's not in the same root or same radical with the same index. For example, B, we have the square root of 7/8. This is the same exact thing as saying to take the square root of 7 over the square root of 8. 8 is 2 and 4. 4 is 2 and 2. So 2 2's pair up. We have 1 left over. So that we are simplifying the square root of 7 over 2 square root 2. Multiply the top and the bottom of this fraction by the square root of 2 to rationalize that denominator. And we're going to have the square root of 7 times 2 over 2 times the square root of 2 times 2, which is 4. The square root of 4 is 2. 2 times 7 is 14, so that gives us the square root of 14 over 2 times 2. 2 times 2 is 4, so that's the square root of 14 over 4. For example C, we have 9 square root of 3 over the square root of 24. That 24 is 4 times 6. 4 is 2 and 2. The 6 is 2 and 3. 2 of these 2's are going to pull out. So we're going to rewrite this as 9 square root 3 over 2 square root 6, or 2 times 3. Now, the reason why I leave it like this is because you have the square root of 3 on the numerator and the denominator here, so those would actually cancel each other out, and you're going to be working with 9 over 2 square root 2. We're going to rationalize that denominator by multiplying the top and the bottom of this fraction by the square root of 2. So we're going to get 9 square root 2 over 2 times 2, because the square root of 2 times the square root of 2 is the square root of 4, which is 2. So then we just simplify it even further to be 9 square root 2 over 2 times 2, which is 4. Again, your 9 and your 4 here do not simplify, so you leave it as it is. For example D, we have the square root of 2 and 1/3. We're going to rewrite this as the square root of the improper fraction. So 2 times 3 is 6, plus 1 is 7 over 3. This is the same exact thing as saying the square root of 7 over the square root of 3. We're going to rationalize that denominator by multiplying the top and the bottom here by the square root of 3. So this is going to give us the square root of 7 times 3 all over the square root of 9, which leaves us with the square root of 21 all over 3. Our next part just goes over simplifying these expressions that deal with variables underneath our radicals. Now, with some of these, you're going to have a different index other than the 2. You can do one of two things here. If you have something like example A, you can just simplify it. If you have something like example B or example D, you can actually rewrite these expressions using exponents that are mixed numbers, or not mixed numbers, improper fractions, and using your rules for exponents. So if you're multiplying them like example B, and your base is the same, keep the base, add your exponents. You want to do, when you're doing these, you want to make sure that all of your variables are positive when they're completely simplified too. So if we look at example A, we have the cube root of xy to the 9th power. This is the same exact thing as saying xy to the power of 9 over 3, which is also xy to the power of 3. Because that 3 is on the outside of the parentheses, it goes to both the x and the y. So that's x cubed, y cubed. For example B, we have the fifth root of x times the square root of x. If you rewrite this using rational exponents, you're going to have the x to the power of 1/5 times x to the power of 1/2. If we use our rules for exponents, our bases are the same. We're going to add those exponents. We're going to do 1/5 plus 1/2. Your like denominator there is 10, so this becomes x to the power of 2/10 plus 5/10. So when we simplify this, we just add those exponents. So we're going to have x to the power of 7 over 10, which this can be rewritten as the 10th root of x to the 7th power. For example C, we have x squared y, all raised to the 2nd power, times the 4th root of y to the 4th power. I'm going to work with both of these separately. So the first thing I'm going to do is work with the x squared y, all raised to the 2nd power. If we sort of distribute that power to both of those terms inside of those parentheses, we're going to have x squared raised to the 2nd power and y raised to the 2nd power. So this is going to give us x to the 4th power y squared. I can't simplify that any further, so I'm going to look at the radical now. My index is 4, my power is 4. So I'm going to divide the power by the index, which is 4 divided by 4, and that gives me y to the 1st power. So I'm doing x to the 4th y squared times y. The power on the y that's by itself is 1. Our rule when we're multiplying variables that are raised to powers, if the base is the same, add the power. You have a y squared and a y, so we're going to keep the x to the 4th power, and it's going to be y cubed now. For example D, we have the 4th root of x to the 8th power over the 4th root of x to the 6th power. You can do this one of two ways. The way that I would do it is I would rewrite these radicals using exponent or powers, rational exponents, and then use my rule of exponent or use my rule of bases raised to a power when dividing, and just subtract those powers. If you wanted to, you could also simplify both of these first and then just rationalize your denominator. So the way that I would like to do it, I'm going to turn this into x to the 8th power divided by 4 over x to the 8th power divided by 6. So with both of these, we can simplify them, but I want to keep the same denominator. I don't know why I put x to the 8th divided by 6. Okay, this bottom one should be, okay, I'm just going to restart this. So x to the power of 8 over 4 over x to the power of 6 over 4. From here, your denominators are the same in both of these fractions. You could simplify them to be 4 over 2 and 3 over 2. It's totally up to you. But I'm going to subtract these exponents since my base is the same now. And this is going to give us x to the power of 2/4, which is the same thing as x to the 1/2 power. If we write it using radicals, it's the square root of x. For our next part, we're just simplifying these expressions and assuming all variables are positive. For example A, we have 8x to the 9th power, all raised to the 2/3 power. This power of 2/3 is telling us to take the cube root of 8x to the 9th power, all raised to the 2nd power. From here, I'm going to simplify that 8x to the 9th power. That 8 is 2 and 4. 4 is 2 and 2. I'm looking for a group of 3. I have 3 2's, so we're going to pull a 2 out. And that x to the 9th power is going to be divided by 3, so that's x cubed. This is being raised to the 2nd power, so we're going to raise the 2 to the 2nd power as well as the x cubed to the 2nd power. So this gives us 4x to the 6th power. For example, B, we have 64x to the 12th power, all raised to the 1/6 power. So we're just going to rewrite this using radicals. We're going to have the 6th root of 64x to the 12th power, all raised to the 1st power, so we do not need to write that power of 1. The 64 is 8 and 8. 8 is 2 and 4. The 4 is 2 and 2. We need a group of 6. We have 6 2s. So there's 2 that we're going to pull out. That x to the 12th power, we're going to divide the power by 6. And that's going to give us x to the 2nd power. For example, C, we have 1 over 4x to the 4th power times x to the 12th power, all raised to the negative 1/2 power. If you would like to, you can simplify what's inside those parentheses first, and this is just going to give us x to the 12th power over 4x to the 4th power, all raised to the negative 1/2. If we were to simplify that fraction inside the parentheses, we're going to subtract the 4 from the 12. So this is going to be x to the 8th power over 4, all raised to the negative 1/2 power. You want to turn that power of that negative 1/2 into a positive 1/2, so take the reciprocal of that fraction. So this is going to give us 4 over x to the 8th power, all raised to now the positive 1/2. The power of 1/2 is the square root, so we're taking the square root of 4 over x to the 8th power. Take the square root of 4, take the square root of x to the 8th power. We're going to have 2 over x to the 4th power when we divide that 8 by 2. For example, D, we have 1 over 9x to the 12th power times x to the 4th power, all raised to the 1/2 power. Again, I'm going to do the same thing I did with the question before this. I'm going to multiply inside those parentheses first. It gives us x to the 4th power over 9x to the 12th power. That x to the 4th power over x to the 12th power can simplify. I'm going to subtract 4 from the 12 and keep it in the bottom since my bigger power is on the bottom. So this gives us 1 over 9x to the 8th power. Remember, this is still raised to the power of 1/2. So when we do this, we're going to take the square root of this entire thing. We have 1 over 9x to the 8th power underneath the square root. We're going to take the square root of the 1. We're going to take the square root of the 9x to the 8th power. This gives us 1 over 3x to the 4th power.